AER stands for Annual Equivalent Rate. Often, banks will pay interest annually, but others, depending on different savings accounts, will pay quarterly, biannually, or even monthly. And in order to compare accounts with these different interest periods, we need to use AER. You'll be given the formula for AER here in your formula book, and it is 1 plus I over n, all to the power of n, take away 1. I is the nominal interest rate per annum as a decimal, and n is the number of interest periods per annum, which means how many interest periods there are during the year. The nominal interest rate is also sometimes called the gross annual interest rate. Here's an example. We want to work out the annual equivalent rate when Kelly has opened a bank account with nominal annual interest rate 4% and interest is paid every 6 months. So just to remind ourselves, the formula for AER is 1 plus I over n to the n, all take away 1. To work out the annual equivalent rate, I'm going to write 1 plus, now instead of I, I'm going to write 4% as a decimal. Remember, I always needs to be as a decimal, which is 0.04. Now, every 6 months, interest is paid, which is twice a year. So n is going to be 2. So I have 1 plus 0.04 over 2 squared, take away 1. I can put this into my calculator. And this gives me 0.0404, which is going to be 4.04%. The extra 0.04%, as opposed to just 4%, comes from the fact that when interest is paid every 6 months, there's an additional amount of interest that is gained on the interest that is earned after the first 6 months in the time between the first 6 months and second 6 months of the year. For B, Kelly invests £2,000 into the account. Assuming she takes nothing out, how much will be in the account after 5 years? To answer this question, we now need to use the annual equivalent rate as the regular annual interest rate of a bank account. So we just need to do compound interest using 4.04% as our interest rate. So we do as normal, final value equals principal times multiplier to the power of n. Final value equals 2,000, so that's what we're starting with. The multiplier is going to be 100% plus 4.04%, which is 104.04%, sorry. So that's what we're going to use as our multiplier. So as a decimal, that's 1.0404. And this goes to the power of n, where n is the number of years, not the number of interest periods, but the number of years, which is 5. So we put that into our calculator. So I have 2,000 times 1.0404 all to the power of 5, and that gives me 2437.99. So that's £2,437.99. And as we discussed earlier, the bank uses AER to fairly compare interest rates. Because again, you might have one savings account that pays money out annually, another one that pays it out monthly, another one that pays it out like this one every 6 months, and you want to compare these accounts, and AER lets you do that. Here's a question for you to have a go at. Please pause the video now and have a go at it, and when you're ready for the answers, press play. Here are the answers. For the first part of the question, we should end up with 8.88% as our annual equivalent rate. And for B, using this as our regular interest rate, we end up with over 3 years, or after 3 years, having £3,872.41 in the account, which isn't quite enough for the car. Very often, we want to use AER to compare interest rates and savings accounts ourselves. And Howard wants to open a savings account. The bank has 2 accounts available. We want to work out which account Howard should choose in order to maximise her saving potential. The account that she should choose is whichever account has a higher AER, because that will effectively mean that that account has a higher interest rate in real terms. So the first one, the Mega Saver account, interest is paid annually. So that's already the AER, 2.16%. The Super Saver Monthly, if we work out the AER for it and compare it to the annual interest rate or the AER of the Mega Saver account, we'll be able to see which is best. So to work out the AER for the Super Saver, I'm going to do 1 plus I, and again, I needs to be a decimal, so that's 0.0215 as a decimal, and that will give us 1 plus 0.0215 over, now this is paid monthly, so the last example it was quarterly, so we divided by 4, but this time it's monthly, so there's 12 months in the year, so it's over 12 to the power of 12 take away 1, so let's calculate that. So we have 1 plus 0.0215 over 12 to the power of 12, take away 1, times that by 100, and we get 2.17%. So the AER for the Super Saver Monthly is 2.17%, which is higher than the nominal interest rate of the annual account. So I would say 2.17% is greater than 2.16%. Therefore, she should choose the Super Saver Monthly. Here's a question for you to try. Please pause the video now and have a go, and when you're ready to go to the answers, press play. Here are the answers. So for the AER for each account, first one we have 1 plus 0.086 over 4 to the power of 4 take away 1. This is the same as earlier, in fact. And for the second one, 1 plus 0.0845 over 12 to the power of 12 take away 1. So we can work out these two values for AER. So obviously as before, the first one's 8.88%. And the second plus 0.085 over 12 to the 12 take away 1, and this one is 8.84%. So we can see, because the second account pays out interest more frequently, even though it's got a lower nominal interest rate, it works out as having higher AER, and that's because it pays out interest more frequently. So there's more time for that interest to itself gain interest over the year. So he should choose account 2 to maximise his saving potential, because account 2 has the higher AER.